All right, finally, we can start talking about sedimentary rocks. Again, in order to talk about sedimentary rocks, we had to talk about where the material that they are made up of came from, right? We had to talk about weathering, we had to talk about erosion. Now we can talk about the creation of sedimentary rocks. There are three types of sedimentary rocks we're going to talk about. Clastic, that's the one that we most commonly think of, but also chemical and biogenic. So clastic, that just means that it's made up of little pieces of pre-existing rock, right? It's the most common sedimentary rock type, and it's most commonly made of silicates, those weather-resistant quartz rocks. So anytime you see a sedimentary rock that just looks like it's made up of bits and pieces of other rocks, that's a clastic sedimentary rock, right? So how are clastic sedimentary rocks created? Well, we've talked about weathering, which is the breaking down of that material. We've started talking about erosion, the transportation of that material. We're going to talk about that more. And then we're going to get to deposition and lithification, right? How the rock is actually created, right? So sediment is transported from a source area to a depositional area, right? That means that wherever the weathering occurs, right, wherever those rocks and minerals break down, they then have to be eroded and transported somewhere else before they form another rock. So they can be transported by wind, water, ice, and gravity. And transportation is going to impact the characteristics of the sediment, of the clast, right? So the farther a grain is transported, the more and more and more it's eroded and weathered, so the smaller and smaller and smaller it gets. That's why if you go up to the mountains, you're going to find really, really big boulders and gravel and cobbles. But if you head down to the beach, you're going to find really small grain size sand, silt, clay, right? So where the material is created in the mountains, it's bigger. It's transported because of water, gravity, and other mechanisms down to the lower elevation where that material is much finer, smaller grain sizes. Not only is the sediment getting smaller and smaller and smaller along its transportation path, remember, it's always transported downhill, or mostly transported downhill, right? Because that's how gravity and water flows. Not only is it getting smaller, the sediment is also getting more and more rounded, right? That's because as it's moving, it's becoming, it's getting abraded. Remember when two rocks run into each other, that's abrasion, it breaks down those rocks. I kind of think of it like taking sandpaper to these rocks, right? The more and more they're ground down, the smoother and the smoother and the rounder that they get. So up in the mountains, you're going to find really angular, jagged rocks. By the time you get down to the coastline, they're going to be more well-rounded and more smooth. Transportation also impacts sediment sorting, right? So up in the mountains, yeah, you're going to find big, jagged boulders and, you know, gravel and big chunks of all different stuff up there. But you're also going to find small sediment too, right? Just because they have boulders doesn't mean the mountains don't also have sand, don't also have clay. There's just more of a mix. So when there's a big mix of sediment and that sediment's all different sizes, all different shapes, we call that poorly sorted. And as that sediment is transported downhill, transported from the mountains down towards the ocean, it's going to become more and more and more well sorted. And this is because the larger grains, the larger sediment is going to be harder to transport. It's heavier, so it's going to stay up in the mountains for a longer period of time. Whereas the finer material, that sand, silt, and clay, it's really easy to transport. So it's going to be very quickly washed down with the rivers, down with the wind, fall down with gravity. And it's going to separate itself out. So by the time you get to the beach, all the material is pretty much the same size, right? You pick up a handful of sand on the beach and it's all the same size sand. You couldn't do that up in the mountains. Right, so in summary, as clastic material is transported, it becomes smaller, it becomes more well-rounded, and it becomes more well-sorted. All right, next up, burial and lithification. This is how that clastic material goes from just being sediment to an actual rock. As that material is buried, more and more pressure is acted on it. So the water and all of the air gets squeezed out. So it's just the solid grains. And then minerals can precipitate out in those voids, fill those spaces, creating a natural cement to cement those particles together. And this is the process of lithification, the process of turning sediments into sedimentary rock. So as rocks are buried, their porosity, or as sediment is buried, the porosity decreases. The porosity is just the amount of space in a rock, right? The amount of space there is for water, the amount of space there is for air, and that porosity decreases over time as that material gets squeezed together and the water and air gets pushed out. So some common clastic rocks. If you're in lab, you're going to see a lot of these. We'll go through them. Conglomerate, right? It's a whole bunch of pebbles all cemented together. Breccia is the same thing, but those pebbles are really angular and jagged. You can have sandstone, where very well sorted sand is cemented together. You can have an Arcos sandstone. These are like pink in color because they contain a lot of feldspar, which is can be a pink mineral. You can get siltstone, right? A rock made up of different silt-sized clasts. You can get shale, which is made up of both silt and clay-sized clasts, right? And every single one of these, if you feel it in your hand, you can actually feel the different grains that are all cemented together to create that rock.